Integrating artificial intelligence, AI, in the semiconductor industry heralds a transformative shift, affecting both the professional landscape and the core processes involved in semiconductor design and manufacturing. This change, while disruptive, also opens up many opportunities for innovation, efficiency, and personal development for professionals within the field. AI encroachment into the semiconductor sector is poised to reshape job roles significantly. For professionals, specific tasks that are repetitive or require extensive data analysis might be automated. An example is Google's use of AI to design the next generation of Tensor processing units, TPUs, resulting in a more efficient chip design than human engineers could achieve on their own. This automation could displace jobs focused on these tasks. Moreover, in manufacturing, AI-driven predictive maintenance, for example, can forecast equipment failures before they happen, minimizing downtime and changing the nature of jobs from reactive maintenance to proactive system monitoring and optimization. This shift could reduce the demand for traditional maintenance roles while increasing the need for AI and data analysis professionals. AI integration into semiconductor design and manufacturing processes also heralds a significant leap in efficiency and innovation. In design, AI algorithms can analyze vast amounts of data to optimize chip architecture for performance, power consumption, and area, PPA. AI enhances quality control and yield rates in manufacturing through precise defect detection and classification, surpassing human accuracy in speed. For instance, companies like Samsung and TSMC leverage AI for real-time monitoring and adaptive control of their manufacturing processes, significantly improving yield rates and reducing waste. Adopting AI is not just necessary for staying competitive. It is an opportunity to redefine what's possible in semiconductor technology. AI as a productivity tool can lead to unparalleled efficiency gains, cost reductions, and quality improvements. It enables developing more complex and powerful semiconductor devices, meeting the growing demand for high-performance computing and several other critical AI applications. Moreover, AI can assist in solving some of the industry's most challenging problems, such as reducing energy consumption and improving the sustainability of manufacturing processes. By embracing AI, semiconductors can lead to technological innovation and environmental responsibility. The evolution towards AI-driven processes necessitates a workforce skilled in traditional semiconductor engineering and AI and data science. Reskilling is crucial for several reasons. As AI automates routine tasks, professionals with AI skills will be in higher demand for their ability to oversee, interpret, and leverage AI technologies. Skilled professionals will drive innovation by integrating AI into new and existing products and processes, ensuring leadership in a highly competitive market. The rapid pace of technological change means that continuous learning and adaptation are necessary. Professionals skilled in AI can pivot and thrive in an evolving industry landscape. In conclusion, while AI presents challenges for semiconductor professionals through job displacement and skill shifts, it also offers significant opportunities for efficiency gains, innovation, and personal growth. Adopting AI and focusing on reskilling the semiconductor industry can mitigate the risks associated with this transition and harness AI power to secure a competitive edge in the global market. The future will belong to those who can blend semiconductor expertise with AI proficiency, making it imperative for professionals and companies alike to embrace this change.